Good afternoon, everybody. Does anybody have any questions from the last class where we talked about area and the relationship of area with definite integrals? I think I left you with some of these definite integrals just to go through and verify. Does anybody have any questions from any of that before we move on? Nothing, nada? Okay. So the topic of today's lesson then is properties of definite integrals. Remember, definite integrals are integrals that have a lower and upper limit, and they represent an area. So definite integrals are a value, a number, whereas indefinite integrals are an antiderivative. So the result is a function. So important properties of definite integrals. I think we've already touched on the first two. The integral of f of x dx from a to a is 0. In other words, if the lower and upper limit are the same, you can interpret that as 0 area, because your start and finish point are the same. So you don't in fact have an area, so that definite integral would be 0. The second property speaks to integrating from left to right and how that's similar to integrating from right to left. The only difference is a negative sign. So if I'm integrating from a to b, the function f of x, integrating from a to b would typically be from the left starting point, which is a, to the right end point, which would be b. That is equal to the negative of the integral when you integrate from right to left. In other words, starting at b and ending at a. So I think we covered both of those in those examples that I did last time. So let's say, for example, that this area in here is a. So you could write that the integral from a to b of f of x dx would be equal to a, because that area is above the x-axis. And you could also write then that the integral from b to a, which is integrating the other way, is just negative a. So this is integrating from left to right, and the second one is integrating from right to left. And you use those properties to evaluate those integrals, or we used, and hopefully you went through the ones that I didn't do, to evaluate some of those definite integrals. Now the third property is written out formally here, but I think we were using it informally, and all that is saying is that if you want to integrate from a all the way to d, then you can break that up into a bunch of different integrals, and in this case it would make sense to break it up into the integral from a to b of f of x dx plus the integral from b to c of f of x dx plus the integral from c to d of f of x dx. Okay, so you can break integrals up, and you can see from what's written there that what the upper and lower limits are. So you would start at A to B and then add from B to C and then add from C to D, and that result would give you the total definite integral from A to D. And those are the three most important properties that we'll be using or have been using. Are there any questions on any of those three before I continue? So I'll take you through a bunch of examples that you would typically see on the AP exam that will require you to use these properties of definite integrals. So the first one, you are given the graph, and you're also given that the area under the curve, the yellow shaded region has an area of 5. That orangey shaded region has an area of 2, and that green shaded region has an area of 1. So you're given that information, and you're also told that the integral from -6 to 0 of that function is 1, and the integral from 2 to 6 of that function is 2. So everything you're given is here now on that piece of graph. And you're asked to use properties of definite integrals to evaluate the following. The first one is asking you to evaluate the integral from 0 to -3 of f of x dx. Now I've written solutions to these things in proper mathematical form, but it's not really necessary if you understand how these properties work. You could probably go right to the answer, and I'll explain that in a second. So you're being asked the integral from 0 to -3. So 0 to -3, you're essentially being asked about that blue shaded region, and you're being asked to integrate from right to left. So we know that the total, starting at -6 to 0, that net area would be 1. So if that net area is 1, in other words, if you're adding that yellow region and that blue region and the answer is 1, then that would mean that the area of that blue region there that's below the x-axis would have to be 4. Right? Because 5 plus -4 would give us the 1, and that would be the integral from -6 to 0. So what I'm saying is this area would have to be 4 if the integral from -6 to 0 is going to be 1, which they gave us. So now you have the answer. The integral from -3 to 0 is -4. So the integral from 0 to -3 would just be +4, which I highlighted there. And so you can do that with common sense, but if you wanted to write it mathematically, you would do it like that. You would write that the integral from -6 to 0 can be broken up into two integrals. You can add the integral from -6 to -3 of f of x dx plus the integral from -3 to 0 of f of x dx. Okay? Now we know the integral from -6 to 0 is 1, which they gave us. We know the integral from -6 to -3 is 5, which we were given. So the only thing left in that expression is the integral from -3 to 0. You just bring the 5 to the other side. So the integral of -3 to 0 would be -4, which means that if I integrated the other way and wrote it as the integral from 0 to -3, it would be the negative of -4, which is +4. So there's a short way to do it, and then there's the formal way of writing it there. Either way is fine. I really don't care if you ever get it on a test. So, any questions on that? Part B, the integral from 4 to 6, is basically asking about the area, that pink shaded area, right? We can look at it as that area. Now we're given that the integral from 2 to 6 is 2. And we know that the integral from 2 to 4 is -1. So that would mean that the area of that pink shaded region would have to be 3. Because -1 plus 3 would give us the integral from 2 to 6, which we're told is 2. So this would have to be 3, because -1 plus 3 would give us this 2 right here, the integral from 2 to 6. And I've written that formally as well. So if you actually want to write it formally using those properties, you would write that the integral from 2 to 6 of f of x dx is equal to the integral of 2 to 4 of f of x dx plus the integral from 4 to 6 of f of x dx. And then you substitute in the values for the integrals that you know. Now we know we're given the integral from 2 to 6 is 2. We're given that the integral from 2 to 4 is -1. Okay, actually you have to interpret it as -1. We're just told that that green shaded area has an area of 1. But if you're integrating from 2 to 4, the definite integral value is -1. And the only thing left in the expression is the integral from 4 to 6. You just you bring the -1 to the other side and we get a value of 3. And that's it. Now we've discovered what all those areas are: 5, 4, 2, 1, and 3. Part C says, what is the value of the definite integral of f of x from -6 to 6? Well, without writing out what I did, because we're integrating from left to right, the yellow, the orange, and the pink are all considered positive contributions, and the blue and green would be negative contributions. So it would be 5 plus 2 plus 3, subtract 4 and 1, and you get a value of 5. Okay, so I wouldn't expect you to have to write that out, but that's how the properties work. Okay, you can just break integrals up into sections. Any questions about C? Now, if it doesn't ask you this here, but if it did ask you what's the integral from 6 to -6 of f of x dx, then that answer would just be -5. Part D is pretty straightforward. The starting and ending point are the same. In other words, the lower and upper limit of integration are the same. So there is no area that we can interpret as that integral, so it's just 0. Part E, let me see if I can, from 4, so starting at 4 and integrating to -6. So we are going from 4 to -6. So the way that I would do this is, if I'm integrating from 4 to -6, then I don't care about the pink region. I only care about the yellow, blue, orange, and green. Okay, so the contributions, normally integrating from left to right, I would say 5 plus 2 is 7. So in other words, if I was integrating from -6 to 4 of f of x dx, that would be equal to 5 minus 4 plus 2 minus 1. Which is 2. That's if I'm integrating from -6 to 4. The question asks from 4 to -6. So the integral from 4 to -6 is equal to -2. It's the negative of this answer we got right here. That's how I would do it. But I've written it out for those of you that want to see it in the proper mathematical form, but it's not necessary. Any questions on that? Okay, the next example comes from a practice exam from 2014. If the sine of 1 over x squared plus 1 is an antiderivative for little f, then the integral from 1 to 2 of f of x dx is equal to which one of those values? So this expression here, the integral from 1 to 2 of little f dx is equal to capital F at 2 minus capital F at 1. That's the fundamental theorem of calculus, which we covered last class, right? What it says is to evaluate that integral, we need the antiderivative, sub in 2, sub in 1, and subtract the 2. Well, we're given the antiderivative. It's the sine of 1 over x squared plus 1. So you sub 2 into that, you sub 1 into that, and you subtract the two values, and you need your calculator in radian mode. They wouldn't expect you to do this without a calculator. And you get that the answer is negative 0.281, which is A. So that's just, they're simply testing you. Do you understand the fundamental theorem of calculus? If you're being asked to evaluate a definite integral when you already know what the antiderivative of that little f is. The next example, again, we're using properties, whether you realize it or not. Properties of definite integrals comes from IPE, stands for International Practice Exam. So this was back from a 2013 International Practice Exam. You're given the graph of f. What's the integral from 0 to 7 excuse me, of f of x dx? So you can break 0 to 7 up into 1, 2, 3, 4 sections. From 0 to 2, which is a trapezoid, and then 2 to 4, which is a rectangle. Then 4 to 5, which is a triangle, and then 5 to 7, which is also a triangle. So I found the areas of those shaded regions, the yellow, blue, green, and pink. The yellow region has an area of 3. The blue shaded square there has an area of 4. The green triangle an area of 1, and the pink triangle, which is below the x-axis, has an area of 2. So the integral, the definite integral from 0 to 7 would be 3 plus 4 plus 1, subtract 2. Why subtract 2? Because we're integrating from left to right, and that area, that pink region, is below the x-axis, so it contributes a negative value to the definite integral. So our answer is 6. Any questions up to this point? Okay, number 7 comes from another practice exam, International Practice Exam. And it doesn't tell you to use properties of integrals, but you need to recognize that we're using properties of integrals. So you're given the integral from 4 to -10, and they tell you that that's -3. And they tell you the integral from 4 to 6 of g of x is 5. and the integral from negative 10 to 6 they want you to find. What I would strongly suggest is that you write all the given integrals with the lower limit as the smaller number. So in other words, write all the definite integrals so that they're integrating from left to right. So I rewrote the first one as the integral from negative 10 to 4 of g of x, that's equal to 3, rather than the other way around when it's equal to negative 3. 4 to 6 is already integrating from left to right, so I left that alone. But now we need an expression that we can write that will use both of those pieces of information. So if the first one integral is from negative 10 to 4, and the other one starts at 4 and goes to 6, then we could write an expression for the integral from negative 10 to 6 of g of x would be equal to the integral from negative 10 to 4 of g of x plus the integral from 4 to 6 of g of x dx. You just add the two numbers, you just sub them in now, 3 and 5, you add them and you get 8, which is D. Any questions on that? The next example is very similar, comes from another practice exam. They tell you f is continuous on a closed interval from 1 to 7, and they tell you what the definite integral from 1 to 7 is. It's 42. And they also tell you that the integral from 7 to 3 is negative 32. Now it would make more sense to write that as the integral from 3 to 7 would be equal to 32, and that's what I've done there. So I rewrote down what they gave me, the integral from 1 to 7, and then I rewrote the integral from 7 to 3 as the integral from 3 to 7, so that all the integrals are integrating from left to right. We're being asked to find the integral from 1 to 3 of 2 times the f of x dx. So we have this additional level of complexity, or this thing, which we can deal with easily by just taking it out of the integral, putting it out in front of the integral. So the integral of 1 to 3 of 2f of x dx is the same as 2 times the integral from 1 to 3 of f of x dx. So how are we going to find that? Well, we take what they gave us. The integral from 1 to 7 of f of x dx can be broken up into two integrals, from 1 to 3 and then from 3 to 7. We know that the integral from 1 to 7 is 42 because we were given that. And we know that the integral from 3 to 7 is 32 because we were given that. So now we can use that, just move the 32 over to the left-hand side, and we would get that the integral from 1 to 3 of f of x dx is just 42 minus 32, which is 10. So the integral from 1 to 3 of f of x dx is equal to 10. We're asked to find 2 times the integral from 1 to 3 of f of x dx. So we take that 10, we multiply by 2, and we get 20. And so our answer is D. So all these types of questions really amount to writing all the integrals so that you're integrating from left to right, coming up with an expression where you break up a long integral into some pieces, and then sub in the pieces you know to find the ones you don't know. That's basically what we're doing in these types of problems. Any questions? Okay. The next two are very similar. I'll go through 83. The answer to this 78 is here as well, but I'll leave that for you guys to go through on your own. The solution is all there. But I'll go through 83. I'll go through one more, and then I want to go through the last two. So number 83, again, you're given this information, these definite integrals. But now we're given information about two different functions, so please pay attention to the integrands. The first two integrals involve f of x. Okay, the integral from 0 to 6 of f of x dx is 9. The second integral is the integral from 3 to 6 of f of x dx, that's 5. But the third integral is a different function. It's the integral from 3 to 0 of g of x dx, that's equal to -7. And they want us to evaluate that expression, the integral from 0 to 3 of 1/2 f of x minus 3 g of x dx. So that integral they're asking us to evaluate, I've broken up into two integrals there that I've written in red. And I took the 1/2 outside the integral sign of the first one. So I can write that as 1/2 the integral 0 to 3 f of x minus the 3 on the outside, 0 to 3 of g of x dx. We have to come up with an expression for that, given those three definite integrals above. So for f of x, I can write that the integral from 0 to 6 is equal to the integral from 0 to 3 of f of x plus the integral from 3 to 6 of f of x. Okay, I have two of those integral values. The first one is 9. That's 9 is equal to the integral from 0 to 3 of f of x dx plus 5. Okay, the integral from 0 to 6 is 9 and the integral from 3 to 6 is 5. That expression allows me to find the integral from 0 to 3. It's just 9 minus 5. Move the 5 over to the left-hand side of the equation, and I get that the integral from 0 to 3 is equal to 4 of f of x dx. So I have half of the required result. Now I just need the other part, the integral from 0 to 3 of g of x dx. So that's written over on the right-hand side. The integral from 0 to 3 of g of x dx is equal to negative the integral from 3 to 0 of g of x dx. Right? That's using the properties of integrals. They tell us that the integral from 3 to 0 is -7, and when I multiply that by -1, I get 7. So now I've got all the pieces, the two pieces I need. I have the integral from 0 to 3 of f of x, which is 4, and I have the integral from 0 to 3 of g of x, which is 7. I just sub those into that expression there that I have written in red. So 1/2 the integral from 0 to 3 f of x dx minus 3 times the integral from 0 to 3 of g of x dx. When I sub those values in, I get 1/2 times 4 minus 3 times 7. And when you work that out, you get -19, which is B. So again, it's the same thing. Write the integrals and break them up. You can write one long integral into a bunch of different integrals added up. Sub in what you know and solve for what you don't know. It's kind of what we're doing in all these examples. And the next one is similar. Any questions about number 83? Okay, so I will leave you to work through this. It's the same idea. Okay, it's a few more calculations, but it's the same idea. Please make sure you understand that. If you don't, we'll go over it next class. But make sure you visit this and understand it. The next example, you're given a graph and you're being asked to tell me which of those, put those definite integrals in order from greatest to least or least to greatest, depending on how you look at it. So you're told, or you're being asked, what is the relationship between the integrals of f of x from 0 to 2, from 2 to 3, and from 0 to 3? So each one of those, the integral from 0 to 2, that definite integral is just the yellow shaded region, which I called area 1. The integral from 2 to 3 of f of x dx is just that blue shaded region below the x-axis, which I labeled A2. Obviously, based on the diagram, A1 is larger than A2. Okay, so the integral from 0 to 2 of f of x dx is larger than the integral from 2 to 3 of f of x dx. A2 would be negative anyways. And then the integral from 0 to 3 of f of x dx would be A1 minus A2. Now, A1 minus A2 is less than A1 and greater than A2. So the answer would have to be D. The integral from 2 to 3 is less than the integral from 0 to 3, which is less than the integral from 0 to 2. So the integral from 0 to 2 is the largest. The integral from 0 to 3 is the second largest value. And the integral from 2 to 3 is the smallest value, obviously because it's negative. So you're just being asked to interpret areas as definite integrals again, and then put them in order from greatest to least or least to greatest. Okay, the last example is probably the most interesting one. And I can tell you that I've put questions like this on tests before, so you may want to put an asterisk beside it. You're given the graph of a function which has a domain from 0 to 7. Okay, so you kind of pretend like all that stuff that I wrote there and colored in isn't there. The graph consists of a quarter circle of radius 3 and a segment with a slope of -1. So the slope of that line there, the line portion of that piecewise function, that has a slope of -1. So I wrote 1, but I meant -1. This should be negative here. Let B be a positive number such that if you were to evaluate the integral from 0 to that value B, the answer would be 0. What is the value of B? So we have to dream up some value of B so that if I started integrating at 0, from the left at 0 to some value of x or some value B, my definite integral would be 0. So you're being asked to understand that the areas above, when you're integrating from left to right, the areas above will contribute a positive value. Okay, so we can find the area of that yellow shaded quarter circle. It's just 9 pi over 4. Then, starting at 3 and integrating towards the right, I don't know exactly how far, but I'm going to create that blue shaded triangle if I start at 3 and I start integrating towards the right. Okay? Those two areas need to cancel each other out in order for the integral from 0 to b of f of x to turn out to be 0. Those two areas need to cancel each other out. Or in other words, they need to be equal to each other. So, where should x be? Should it be between 4 and 5, 5 and 6, 6 and 7? It can't be beyond 7. It has to be before 7. So I randomly drew a line down and I let that value be x. You can see the distance there in blue. I wrote that as x, somewhere between 6 and 7. That was arbitrary. You can draw it wherever you want, but I'm going to let that distance be x. And then because the slope of that line is -1, the height of the triangle, which extends below the x-axis, is also equal to x. If I go over x and the slope is -1, then I have to go down x. Okay? So the dimensions of that blue triangle are x and x. They're equal to each other, and that's because the slope of that line is -1. So if I find the area of that triangle, it's 1/2 x times x, which is x squared over 2. So if the value of our integral is 0, I said it before, then a1, the shaded yellow quarter circle, has to be equal to a2, which is the blue shaded triangle. So x squared over 2 has to be equal to 9 pi over 4. So I can solve that for for x, and I get x is 3.7599. That doesn't mean that b is 3.7599. Okay? X is the distance starting at 3 and moving to the right. So x is a distance of 3.7599, which means b, the upper limit of our integral, is 3 plus that. So it's 6.7599. So what that means is if I started at 0 and I integrated all the way over to 6.7599, the value of that integral would be 0. So the answer is D. Any questions on that? It's a good question in my mind. Nothing? Okay, that's it for today. Unless you guys have any questions. So that's just to give you a heads up, at some point soon, I'll probably be assigning you some work to do, like an assignment where you're going to be handing that in. And I don't know whether we're going back to school or not on the 16th. But whether we do or not, we're going to have a test coming up soon. It'll probably be in the next couple weeks. If we have to do it from home, then we'll figure out a way to do that. But just to give you a heads up, you're going to have an assignment and probably a test coming up. And that's all I got for today, folks. Please make sure that you understand all the examples that we've been going through in these notes, in these lessons over the last few classes. Next class, we're going to review how do I evaluate all the different ways that we can evaluate definite integrals. So that'll be next class. Any questions? If not, you're free to go. Have a great day, folks.
Thanks, sir. Have a good day.
Thanks, bye, sir. Have a good day.
Thanks, sir. Have a good one.
Thank you.
Bye, sir.
Bye, sir. Have a good day.